Show that the buoyant force is due to the difference in pressure between the upper and lower surfaces of a cube completely immersed in a fluid of uniform density. Let's begin by illustrating a cube. So suppose we have a cube a certain distance below the surface of a lake, for example. So to make things easy, we're going to say that this cube, I guess cubes have equal lengths of sides, so every side has an area of A. Well, let's look at the pressure between the top surface and the bottom surfaces. So let's just call the top surface, let's just create a reference here. And that reference height will be a reference height where I'm just going to label a point. So let's take a side view of this cube. And let's look at the pressure difference between the upper surface of the cube and the lower surface of the cube. So let's say the upper surface of the cube experiences a pressure of P naught. Let's say the lower surface of the cube experiences a pressure of P1. Now remember, pressure is defined to be force over area. So the pressure at the top surface is given by the force at that top surface over the area. The pressure at the bottom surface is given by the force at the bottom surface over the area at the bottom surface. So that's essentially a force bearing down on the upper surface, and I am calling that force F naught, and a force bearing up on the lower surface, and I'm calling that force F1. Remember, the areas of those surfaces is A. So just to kind of remind us in the picture, I'll just go ahead and make this kind of three-dimensional. So the upper surface has area A and the lower surface has area A. I drew the forces on the upper and lower surfaces of different magnitudes because I know that the pressure in a fluid increases with depth. If the pressure increases with depth, the force per area also increases with depth. So I know that the force pushing up on the lower surface is going to be greater than the force pushing down on the upper surface. So let's look at the difference in pressure between the upper and lower surfaces. So the pressure at the lower surface is equal to the pressure at the upper surface plus rho g times the difference in height, or the difference in depth between those two surfaces. So at surface 1, I'm going to say that is a depth of y1. Surface 2, I'm going to say that is a depth of y2. And I'm going to just make my depth axis going down being positive. So we know pressure is equal to force per unit area. So the pressure at the lower surface is going to be the average force on that lower surface per unit area. Pressure on the upper surface is the force per unit area on the upper surface. And then this is plus rho g, and I'll just call that the height of our cube. So I'm just defining the height as being the difference between the two depths. So I'm going to multiply through everything by the area. Notice this quantity here, or a cube, area times height, that corresponds to the volume of the cube. So I'll write the force on the lower surface equals force on the upper surface plus the density times the volume times the free fall acceleration of gravity. But remember, mass equals density times volume. So this is the force on the lower surface equals the force on the upper surface plus mass times gravity. So we should recognize that this density is the density of the fluid we are immersed in. So this mass corresponds to the mass of the fluid that we are immersed in. So if we look at the difference of force between the upper and the lower surface, the difference of force between those two surfaces is based off of the weight of the fluid displaced by our object. Now, this difference in force is what we call the buoyant force. So this shows us that the buoyant force is equal to the weight of the displaced fluid. Now, how did the buoyant force arise? It arose because of a difference in pressure between upper and lower surfaces. If there is no difference in pressure between the upper and lower surfaces, then there would be no upward force acting on our object. So here, if we go back to this picture, we see that if we have an upward force counteracted by a downward force on the upper surface, notice the difference between these two will still have a net force going up. And that net force going up corresponds to the buoyant force. And that is all due to the fact that there is a difference in pressure between the upper and lower surfaces of our object immersed in a fluid. And, maybe actually a better way of saying that is that the buoyant force is due to the difference in pressure between the upper and lower surfaces of an object completely immersed in a fluid. But more accurately, the buoyant force is due to the amount of fluid displaced by your object. And that amount of fluid that's displaced has a weight. And the weight of that fluid corresponds to the upward force that the fluid exerts on the object.